Okay, slides are visible. Okay, so we'll start. So once again, good morning to everyone. Today we are going to study the various types of degradation functions. Okay, so before start with the degradation functions, we'll revise the various types of noise models. Okay, so my screen is visible. My voice is clear. Yes, I am audible. Hello. Yes, my voice is clear. Okay. So in last lecture, we can study the different types of noise models. Okay. So these noise models are too important as per your exam point of view. Okay. So how the noise can be added in the image, or what are the different types of noises are present in the image. Okay. So how the noise can be added in the image. So by two possibilities the noise can be added in the image. Okay, so first possibility is at the time of image acquisition, and the second possibility is the at the time of image transmission. Okay, so when we capture the image, that is called as the image acquisition. So due to the various interference, or we can call as due to the intensity of light. Okay, so we can focus the light on a particular object. So when we capture the image with the help of particular cameras, so at that time there is a possibility to add the noise in an image. And the second possibility is that at the time of image transmission, so might be when we transfer the spatial domain information into the frequency domain information, so at that time there is a possibility to add a noise in an image. Okay, so what are the different types of noises which are presented in the image? So here we have to study the different types of noises and how the noise can be represented with the help of mathematical equations as well as with the help of plot functions. Okay, so that part we cover in a last lecture, so simply we can revise it. So the different types of noises are, so Gaussian noise, Rayleigh's noise, gamma noise, exponential noise, uniform noise, salt and pepper noise, and a periodic noise. Okay, so we can study the different mathematical equations and a plot functions for a different type of noises. So here we can represent the mathematical equations as well as the plot functions of a different noises. So it is difficult to identify by visualizing any image which type of noise can be present in the image. So that's why we can do the mathematical modeling of a particular image. So here we can take a one example, so which consists of a black color, white color, and a gray color. Okay, so when we take such image, and we can observe which type of noise can be presented in a particular image. Okay, so if we simulate this particular image, then we can easily visualize the structure of a particular noise. So it might be a Gaussian noise, it might be a Rayleigh's noise, or it might be a gamma noise. So by observing a particular plot function, we can easily identify this type of noise can be presented in the image. So it is difficult. Only by observing the image we cannot identify which type of noise can be presented in the image. Okay, so but in case of a if we consider a salt and pepper noise, okay, so we can get a little bit idea So if a small dots are presented on an image, we can identify it is a salt and pepper noise. But for exponential noise, Gaussian noise, so that noise we are not able to identify by only looking at the image. So that's why we can simulate the image and we can easily identify such noises presented in the image. Okay, so we can study the 6 different types of noise models, its mathematical representation, and its a plot function. Okay, so here the noise can be presented in the image. So if the noise is presented at a center of an image, that is called as a Gaussian noise. Okay, so by looking at the plot function and its mathematical equation, we can easily identify the various types of noises in an image. Okay, so now we'll move towards the next point, that is called as a estimation of a degradation model. Okay, so in first lecture also we can study the degradation model of an image. Okay, so it is a basic need of degradation model. So when we restore the image, so we can study the image restoration. So it is a image restoration. So simply we have to restore the image which is affected from the noise. So for that we can take the example of a pen drive which is affected from the virus. So simply we can scan it and we can remove the virus. So similar in an image, if the image is affected due to the noise, that image is called as a degraded image. So we have to remove the noise from the degraded image. So that is called as a degradation model of an image. So in degradation model, we can use various types of filters. Okay, so that's also called as a estimation function. So for image restoration, we can use the 2 types of filters. One is the inverse filter and another is a Wiener filter. Okay, so the inverse filter and a Wiener filter we can study the later. Okay, so similar in image enhancement also we can study the different types of filters. Okay, so can anyone tell which type of filter we can study in a image enhancement? Yes, can anyone tell which type of filters can present, yeah, which type of filters we can study in a image enhancement? In our third unit we can study the different types of filters. Can anyone tell which type of filters we can study in a third unit? क्या आठवत है? Yes, Sushant Aldar. Yes, which type of filters we can study it in an image enhancement? Okay, one is a low pass filter. Only, only we can study the low pass filter. Yes, Sushant is there. Sushant Aldar, Vikram More. Yes, which type of filters we can study it in an image enhancement? Rutuja Chavan. काय आठवतंय का पाठीमागचं? Yes or no? Okay, so we'll continue. So in an image enhancement, we can study the various types of the low pass filter, high pass filter, then Butterworth filter. Okay, so basically the filters can be used to remove the unwanted noise which are presented from an image. Okay, so in image enhancement, we can study how we can improve the quality of image. Okay, so along with how we can remove the noise which is presented from the image. Okay, so by using the filters we can remove the noise. So similar to that, in our image restoration we can use the two types of filters. Okay, so now come towards the estimation of degradation model. Okay, so as we study, okay, so as we study in the degradation model, we can use the degradation function. Okay, so the degradation function can be represented with a letter H. Okay, so when we study the degradation model, we have to estimate the degradation function. Okay, so the degradation function can be represented with a letter H. So now we have to calculate the degradation function. Okay, so when we use the degradation model, so in degradation model we can use the two blocks. One is a filtering function and another is a degradation model. Okay, so when we study the degradation model, first we have to estimate the degradation function H. So there are three techniques to estimate the degradation model. Okay, so we have to study the three types of techniques. So by using any technique we can estimate the degradation function. Okay, so there are three techniques which are: first one is a estimation of a degradation model by observation. Second one is estimation of a degradation model by experiment, and third one is a estimation of a degradation model by mathematical modeling. So we have to study the three techniques. So first one is a by observation, second one is by doing a experiment, and third one is by using the mathematical modeling. Okay, so first we need to understand what is the observation, what is a experiment, and what is a mathematical modeling. Okay, so these three techniques are too simple to understand. So first one is a estimation of a degradation model by observation. Okay, so now everyone listen carefully, how we can estimate the degradation function by using simply observation. Okay, okay, my voice is clear. ऐकू येते का व्यवस्थित? Hello. Okay, so now everyone listen carefully. So these three techniques are too important. How we can estimate, yeah, how we can define the degradation function. So okay, so to remove the noise or to define the degradation model, these three techniques are too important. Okay, so the first technique is a estimation of a degradation model by observation. Okay, so as a name indicates, so here we can use the word as a observation. So simply we have to observe the images. So by looking at an image we can compare the difference between the two image. So that's why we can called as a estimation of a degradation model by observation. So by looking at the image, we can easily identify the difference between the two images. So for that, we can take a two images. So might be it having a rectangular shape. Okay. So when we estimate the degradation model, so we have to convert the spatial domain information into the frequency domain information. So here we can observe the two rectangles. Okay, so in first rectangle we can observe a small square. Okay, and in a second rectangle is a only the plain rectangle. So by looking at these two rectangles, we can compute the degradation function. Okay, so the degradation function can be noted with the symbol letter H. Okay, so here we can easily identify the difference, yeah, the similarity between the two images. So by looking at an image, we can easily identify the change in a particular image. So that's why it can called as a estimation of a degradation model by using a observation. Okay, so simply we can observe a image and estimate the degradation function. So that's why it can called as a by observation. Now the second is by doing a experiment. So we have to simulate the image and we have to define the degradation function. So for that we can take an example of impulse response. Okay, so everyone focus on a two images. Okay, so in first image uh, we can find out a small white dot in an image. Okay, so for that we have to estimate the impulse response. So we can simulate the particular image, and after simulating a particular image we can find out the impulse response of a particular image. So if we observe the second figure, so we can easily identify there is a change in a brightness of a particular small white dot. So that referred as a impulse response. So observe the two figures. So in first figure we can take an example of only impulse, and in a second image we can draw the impulse response of a particular white dot. So that is called as a by doing a simulation, or we can call as a by doing a experiment. Okay, so when we do the experiment, so we have to use the mathematical terms. So here we can use the impulse image. So to represent the image, so we can represent the image by using a function f of xy. So that is called as a impulse image. So we have to convert the xy coordinate into the u comma phi coordinate. Okay, so by using the mathematical equations we can convert the x y coordinate into the uv coordinates. Okay, so this technique is called as a estimation of a degradation model by using the experimentation. The third technique is called as a mathematical modeling. Okay, so in mathematical modeling we can use the various mathematical things. So we can use the various coordinates. Okay, so by using the some mathematical functions we can also define the degradation function. So here we have a one mathematical formula. So the degradation function can be represented with the letter h. So here we can represent the formula of H. So H of UV. So this is nothing but the degradation function, or we can call it as a estimation function. Okay, so when we consider this function, so at that time there is also a disturbance, which also called as a turbulence of a nature. So by using the turbulence, we can also identify, yeah, we can also identify the quality of a particular image. So now observe the next slide. Okay, so here we can take the example of various turbulence. So when we change the turbulence parameter, so it is defined in terms of a noise. So when we change the value, the quality of image can also changes. So observe this four figure. So in first figure, we can call as a negligible turbulence. So in second figure, we can define the turbulence as a K is equal to 0.0025. So similar to that, we can change the turbulence factor. So as we change the turbulence factor, the quality of image can also be changed. Okay, so by using these three techniques, we can also judge the noise level, and we can also identify the quality of a image. Okay, so these three techniques are important. So first one is a by observation, second one is a by doing a simulation, that is called as a experiment, and third one is a mathematical modeling. Okay, so in mathematical modeling, we can use the noise factor, or we can call as a turbulence factor. So depending on the value of turbulence, we can easily observe the change in a image, yeah, change in a noise level. So if we observe these four diagrams, okay, when the turbulence is negligible, so at that time the image is more clear, so as compared to another images. Okay, so this is called as a mathematical modeling. So by doing a observation, by experimentation, and by mathematical modeling, we can estimate the degradation model. Okay. Okay, and the next point, when we use the degradation model, so we have to use the filtering element. Okay, so in filtering element, we have to use the two types of filter, that is a inverse filter and winner filter. Okay, so we have to study the two types of filters. Okay, so first one is a inverse filtering, and another is a winner filtering. So in these two types of filter, we have to study the degradation model or a estimation function H. Okay, so these two filters are also too important. Okay, so this is the last point, our fifth unit. Okay, so our fifth unit consists of only 3 to 4 points. Okay, so first point is a degradation model, second point is a noise models, third point is a estimation of degradation model, and the fourth point is a filtering element. Okay, so the two types of filter we can study in our next lecture: inverse filtering and winner filtering. So the fifth unit consists of only the 4 points. Okay, so in exam also there is a questions on a any 2 points. It might be a any filter, or it might be a degradation model. Okay, so the fifth unit consists of only 4 points, but these 4 points are too important. Okay, so first point is a degradation model, second point is a noise models, third one is a estimation of a degradation model, and fourth point is a filtering element. Okay, okay, so the two types of filter we can study in our next lecture. So if you have any doubts in these three steps, so you can ask here. What is the observation? What is the experiment? And what is the mathematical modeling? Okay, so this is a total mathematical parts. Okay, so when we do the simulation of a particular image, so at that time we can easily understood what is the observation, what is the experiment, and what is the mathematical modeling. Okay, so by using these three technique we can compute the noise level in an image. Okay, so the two types of filter we can take in our next lecture. So if you have any doubt, you can discuss here. Yes, do you have any doubts? ऋषिकेश मोरे, काय डाऊट आहे का? Yes, ऋषिकेश. Okay, so put your number by using your proper sequence. So don't put number randomly. Sanjay Pawar. Okay, so those who put your numbers, you can let know.